Hello everybody, welcome back to another video. I'm hoping you guys are all having a absolutely fantastic day. So in today's video, as you can tell by the title, yes, we will be finally talking about the potential for some sort of a snow system. The details are very minimal. This is a very far out storm. The confidence is very low. However, there are growing signs, and a trend is your friend, right? So regardless if this one doesn't happen in the manner I'm forecasting today, I will keep you updated, and it looks as if sometime in the next 15 days there will be some sort of system across the western slash northern United States. Again, this won't be just secluded to the mountains. This will be affecting lower elevation areas, which is why I could call it a snowstorm, not just high elevation snow from a rainstorm. Kind of a difference there. But yeah, it's definitely looking exciting. A lot of things to talk about. And before we get into this, if you guys would like to support this channel, if you like what you're seeing, obviously don't do this if you don't like what you're seeing. But if you do, consider subscribing once you watch this video. Consider liking this video. And if you have any comments, concerns, questions, leave them down below. And let's start talking about this. So I want to actually go to a different website right now, and it's called, well, I want to show you the radar. And what I want to show you is a lot of the rain across the United States. So there isn't as much really in terms of coverage, but it's across a vast area, if you will. Notice that it's stretching anywhere from the Gulf Coast of the United States all the way into, well, southern Canada. And it is all rain. It's not snow. It is actually very warm for October 1st. I think my location is, yeah, you can see right there in the mid 80s, low 80s. Here in my place, it's almost 84. It is very warm. Today I walked out and I was like, holy cats. I mean, it feels like summer, and it truly is. That's a high temperature you would typically see in early August. So, yeah, no signs of snow in this short term for sure, especially with such a heat dominant air mass. But look at this, that really makes sense, but heat dominant, more like just a hot air mass. Notice that there are showers, and they're very slow moving. Notice that they have conglomerated in certain areas more than in others, but what this will continue to do in the next 1 to 2 days is shift to the north and east, affecting many areas with rain. Not many areas will see a ton of rain. There will be some areas that will see 1 to 2 to 3 inches of rain potentially, but those are localized areas. It will most likely, this system, produce large, widespread amounts of up to kind of half an inch, maybe an inch, so not a ton. Now this is just one of many models, and I want to show you what it shows with this system that is currently being shown on the radar, and what the system will do in the next few days across the Midwest. So notice, it juts itself again further to the northeast every single day. Here's your timeline, October 1st, 30 hours out, and you can see there are the dates, but really here it's much more visible. And notice, just track your location. We do see light rain. You can see nothing too significant. The low pressure isn't really well defined, but it is providing us with a decent area of showers and storms that is, again, rather impressive for how unorganized the system is. And as we push this forward, you can see it does take its sweet old time. At this point, this is 70 or 60 hours out. It is 7 p.m. On Sunday, and you can see it's really across much of the same locations that it will be as early as Sunday. And then into Monday, moves into the northeast. It really just kind of slugs its way into the northeast. You can see kind of weekends, not much shower activity going on, but by Tuesday in the evenings, Tuesday late at night, Wednesday morning, it's just kind of centered across the southeast, kind of has dissipated towards the northeast. But what we see is more showers across the southwest. And look, this system actually reinvigorates itself with the tropical moisture. And look, it sends showers back into potentially Illinois, Indiana, Michigan. Not much, but enough to cause cloud cover and potentially some wet rain or some wet conditions. Rain is obviously wet. Well, there is an argument of whether or not water is wet. You can see that obviously cloud cover, rain showers, nothing too impressive, but definitely enough to really keep it more dreary and potentially a bit on the cooler side with that cloud cover. But again, rather warm. Now, what do we see? Well, we see, so again, that's the first system, right? And I want to say that some models show the system a bit more vigorously than others. For example, the Canadian, through this 150 hours out into the next week, you can see it shows that same system into Monday, Tuesday, Wednesday, right? But look, it really just keeps it there for a good while, and much more stronger than what the GFS shows. And this model actually, look, brings it back way into Michigan, Illinois, Wisconsin, not just causing cloud cover, obviously, but some, some wet soils, wet conditions, and quite a bit of rain in some areas. So obviously a lot more rain coming out of this. And I just want to show you the rainfall amounts across the eastern United States through this time frame. You can see many locations don't get a lot. Some will get up to maybe 2 inches. You can see a few isolated spots. It does show a few areas where the thunderstorm activity may be a bit more enhanced by the tropics, receiving up to several inches. But again, that area of heavy rain is, kind of a guess. We don't really know if it does happen, where it will happen. The Canadian shows it right there across Jersey, and the GFS, well, it disagrees. It shows it further to the south across Georgia, and it shows much less to the north across Indiana, Michigan, and Illinois, Ohio, Kentucky. Seeing up rain, right, but not a lot of it. Now, this is where things start getting fun and interesting regarding that pattern change that I talked about, and again, that potential snowstorm that I am now touting about in this video. So let's get into this. Notice, we do still have tropical activity off the coast of the southeastern United States. That will continue to plague the east with showers and storms and moisture. So again, I just want to say that that's going to be happening, but I want to focus my attention to here. Notice, we do have little bouts of precip from the southwest. That's good. It'll bring some rain into Arizona, New Mexico, Utah, Southern California, but that's not really the system that we're looking at. What we're looking at is a lot of moisture coming in from the west, and you can see kind of what's left behind from that system. And each model run, let me tell you, this differs. But you can see this GFS develops a pretty nasty system. Not a snowstorm, but by next weekend, we do have some sort of a system that is dropping snow in high elevation areas, but it's more of a rainstorm, right? And it's fair to call it that. But it does bring some nice rain, and it moves itself out of there. Now, even if the snowstorm doesn't occur in each of the model runs, I want to point something out. So notice the characteristic of that storm, right? It has a nice little backside of it. It has trying to make a cold front. Not the best example of a fall storm, but compared to this one, right, with little to no circulation, just these showers, kind of like more of a summertime system. This one has more of a close-off circulation and is much stronger. And look, the one that follows that, that's not really a system if you want to call it that. That's just kind of a little area of showers, a shortwave. But look, the next major system that follows that is associated with cool air. It's a lot of moisture from the Pacific, and obviously once it's in the mountains, it can't really form a circulation. But as soon as it comes out onto the plains, look what the GFS does with it. It circulates it for a while across Idaho, Montana, dropping quite a bit of snow. That could be very beneficial, and it could drop actually decent amounts of it because of how cool it could be. And let me show you the anomalies. One area of the country that will be below average, if not just average, is the west. Everywhere else it's going to be warm, and that compiles with quite a bit of precipitation at that same time. So snowfall will be inevitable for at least the higher elevations. Look at that. That's a decent system into Calgary, potentially Alberta. That's almost inevitable. And then look, the GFS develops this bomb system right there. Boom, very strong, 979 strong winds, probably a blizzard if this were to occur in this feature. Montana seeing its snowstorm, western portions of North Dakota, and maybe even northwestern extreme South Dakota. And look, that thing spins away, develops a cold front, extreme winds. Again, not the best conditions, but it's a large system. And look, notice that the GFS brings in another wave of precipitation with similar cold air, snow, and precip. And it doesn't go far out enough, but you could imagine once this moves onto the plains, it would develop into another large system of magnitude similar to this one. So what I'm trying to say is here, even if each model run shows something different, for example, look at this 6 o'clock one. This one, I recall looking at it, and it didn't show any. Yeah, look at that. It developed this system at around the same time frame, but it developed a decent one away from the Rockies, and it didn't have enough cold air, and it did have that characteristic. You can see it tried developing that in circulation, but it's too far. It didn't have any snow on the backside of it. And look at that one right there. Same thing. A bit further away, but it's strong. It's a strong system. They have all strong circulations, and that is very noticeable during the fall every single year once that starts happening, because usually these are powered and allowed to strengthen to such levels because of the jet stream, and that's why they're faster. They're not like summer storms like the one we're seeing right now kind of across the U.S., just kind of meandering, sizzling out, and petering out after a week. These, they're gone in in a few days, but they are strong, and they will show their presence while they're there. And you can see it develops a snowy side, but a bit further towards the north. And the thing is that with each one of these storms, different model runs show different scenarios, but all it takes is one of these systems to take one of these tracks, really even something like this, where it's further out right here, and we just need a bit of that colder air, which some model runs again we're showing, especially across the northwest. And when you have such a large system, a lot of this snow, like in this storm right here, or a lot of the precip could turn into snow, and that could, the models are favoring this location for a decent system. So regardless of if not that snowstorm happens, there will be storms that are capable of producing snow as long as there's a little bit of cold air, which is probably the biggest kind of bottleneck to this, as there has been a lack for sure of cold air and an abundance of warm air. But notice they are fueled, and with this the GFS, this is the 6 o'clock one, so notice it showed a lot of rain obviously where those storms occurred. Look at that, that is good rain for the west, even portions of California, the Sierra Nevada. That is very beneficial, already more than what we saw last year at this time. The La Nina looks to be pretty darn good this year for the northwest. I think last year it was just kind of confined to Oregon, Washington, southwestern Canada, and it wasn't even really snow, it was just rain. But look at this, ready? Let's take a look at the newer one. It also shows quite a bit of rain, even more across California, but in terms of it doesn't show maybe as much rain across the plains, but look, it shows much more snowfall. Again, taking a look at our 384, look into Montana, even Dakotas, it shows a bit of snow into Idaho, several feet into the Sierra Nevada, and much Calgary right there, seeing over 6 inches of snow, and that's a pretty large city in Alberta. So you could see that the chances of a pattern change are likely. As you can see, a lot of the snow's here, not here across eastern Canada or southern Canada, because it's way too warm, but definitely starting to look chilly and colder here. And again, I think that that cold air can sneak out, kind of conjoin or attach itself to a system that's going from the southwest to the northeast, and that could produce a large swath of snow across the Dakotas, maybe again Montana, the southern Canada, and really a lot of models do support this. So the European, it only goes out to 240 hours. You can see right there. So it doesn't show a snowstorm because it's not as far out as what the models are kind of favoring for the time when they do show that snowstorm. It's a bit further out than what the European goes out to. But what the European does show is cooler air sneaking into the northwest, an abundance of precipitation, and again, favoring for those large systems with a large circulation. And you can see right there, boom. I mean, that is a nasty, nasty system. And for example, this European model run doesn't show any snow on this. But, if it were to be a bit colder, a lot of this could turn into some snow. Maybe not significant because, again, of how limited the cold air is. Or it could just change the orientation of the system, bring it closer to the mountains, and then that could produce snow for much of Dakotas, really North Dakota, Minnesota, Wyoming, Idaho. But, this one doesn't, but at least it shows that big circulation pattern with those systems. And look, right there, we have a blast of cold air. We have a system. We have some moisture coming in from the south. If this were to go out in another 100 hours, we could be seeing another large system developing. So, the message is a lot of precipitation for the west. It seems, especially the northwest. You could see right there. That's not even bad for the southwest. Those are decent amounts. The east, the Midwest, the south, also seeing decent rains. Again, this is mainly to do with that system that we're going to be seeing this week and into this weekend. But yeah, also across the plains, especially if you see those beasts of circulation systems coming through, right? I guess that's what I call them, even though just fall storms should be more appropriate, but I want to be more specific. Fall storm, I like to kind of categorize it with a strong cold front, that powerful warm front, right? So it has a warm front, a cold front, and it has a giant shield of precipitation, snow, rain, whatever it is, depending on how much cold air there is available. Now, again, so those are the two models I wanted to show you. I did start showing you the Canadian, but I only showed you it's out to 150 hours just to show you that summer storm that is occurring. And look, again, it is going to be occurring. Quite a bit of rain will be falling. I'm not focusing on it because, again, it's not as exciting as what could be going on across the northwest, but it's one of these models, the Canadian, that again keeps the system around for a while. Look, into Thursday, it's still there. I mean, it's kind of a different phase of the storm, but it's still there, bringing shower, storm, cloudy weather. That's good though. At least it will be curbed, some of that heat with some of that cloud cover. But look, the Canadian, it shows that chunk of precipitation across the southwest again, California, Nevada, Utah, and look, there's our system. Boom, it develops into a strong system. It seems that there will be several of these low pressures. The first ones maybe not have snow on the backside. You can see this one's really snow-free. And again, it may not be. It could turn into more of a snowy system if there's more cold air available. At this point, though, the models don't think so. But then look, all the models start showing a cool blast of air. Nothing unusual, I would say, because again, we would usually already see something like this at this time of the year, but this year has been delayed. You could see, yeah, right there, the anomalies aren't significant. They are compared to what we've been seeing, and actually right there, the Canadian does favor some pretty chilly temperatures. I would say this is over exaggerated. The Canadian often does this, but definitely chillier temperatures because the European and GFS also show that. And obviously, you could see it shows precipitation coming in from the Pacific, coming in from the north, coming in from the south. Again, all it takes is just kind of a coupling of all of these, and it could produce a nasty system and a snowstorm. So I do think that early indications are showing some signs of a snow system. One last thing I want to show you before I go: European members. So this is an ensemble. I just showed you 3 models that are often used in making forecasts, especially out to like 100 hours. But when you're looking very, very far out, you want to look at many, kind of want to look at as many sources of weather information as possible. And these are 51 individual models that make up one kind of conglomerate of called the European members. And I just put on 15-day snowfall for the United States. And each time the image shifts, it's a different model interpretation. So you can see this one favors a lot of snow. Look at that. And Wyoming, Idaho, Montana. I could show you each individual model like I did with this, but I just showed you 3 and it took me like 10 minutes, probably more. I'm not going to show you 51 models, so I'll just show you each one of them, but their snowfall outlook for the next 15 days. And let me just click through this and notice if you see a trend. And look at that. There, right there, a snowy scenario all the way into Nebraska, Kansas. I wouldn't say this is likely. This is a bit too aggressive from this model, but I'm trying to show you that the models I showed you aren't even the more aggressive ones, especially the Canadian and European, because they don't go out far enough. All of these go out much further, the 384-hour kind of timeline. Here's another model. You can see it shows quite a bit across the mountains into the Dakotas as well. It starts painting something, a pattern change for sure. Here's one that keeps it way to the north, but still, look at those profound snowfall amounts with every single model across the mountains of southwestern Canada. And look, some bring a giant system, maybe a bit further eastward, but it all seems like a big pattern change. It's on its way, and look, every single model run. Some do show less like this one, but look, and look at this here in Nevada with each one of these. It's favored to see that snow, which is actually pretty brilliant information, and the positive, brilliant information. They need that snow. And if you were to put this forward, notice what we see is, look at that, Wyoming, Utah, Colorado, the Dakotas. This one doesn't as much. Look at this one, blows it up. Also, very snowy. This is more of the higher elevations, but still a snowy pattern that obviously needs a lot of precip, so you can imagine that the lower elevation areas would see a lot of rain and a lot of chillier air than what we're seeing. Maybe not the normally cold, but chillier compared to what we've been seeing, which again, it's been very warm, so I guess it doesn't take much to see a chillier air. The bar isn't really set high for that, but look, there's many models that take the snow out into the Dakotas and Wyoming, many more than what we had a few days ago. Look, it's almost every other model does it. Look right there, obviously not every single one. The ones that are more conservative still show a lot of snow, but into the mountains. Look at this one, a little bit more into the mountains. This one's further towards the plains. Again, not just the higher elevated areas. And as we push this forward, we do see again that variation continue. Some bring it stay more into the mountains. Some again, more of just a warmer pattern. You can see that doesn't even support much of precip or snow from higher elevations. But again, I would say that's more of the outlier. Right there, you could see another system another model that supports snow, another one right there. And, I can't show you the individual systems with this. I can, but it would just take too much time. But you can imagine that even the models that are more drier like this, they do have those large, we could take a look at this one individually, and they probably do have a large system that occurs. They just don't think they will have enough cold air with it. And the models that show a lot of that snow, they're probably showing a very similar system. They just think that there will be enough cold air for it, and that's why they put out the snow. And I don't know if this is loaded enough for me to do this, but I want to take a look at the EPS. Let's go to the United States, and I want to find a model run that is a bit drier in terms of the snowfall. Not as so P34. Let's remember that. Let's go to the precipitation type and MSLP and see if we could play it out. There we go. So model 34, and let's see what it shows. Kind of playing it out like what I did at the beginning of the video with the 3 major ones. Again, so this is just one ensemble, so it's a weaker kind of, I guess, model than the three major ones I showed you, but let's see what it shows. So again, it favors that rainstorm across the southeast. Look, it brings in precipitation across the northwest. Again, this is a model that doesn't favor a lot of snow for the northwest. It keeps it a bit, it definitely keeps it a bit less snowier based on the total snowfall. But look what it shows. It still shows a lot of activity across the northwest, and it does show that at first with smaller systems. But look, towards the end, right there, there's a little piece of energy that goes through the Dakota, South Dakota, Minnesota. It's disconnected from the snowy side that it shows right there into Idaho, Montana. So it doesn't kind of show that, again, that coupling of those storms. But look, there's a pretty decent system of fall characteristics across Missouri, Illinois. Obviously, that would be way too far to produce any snow. But you can see that it's still kind of starting to show those systems, each with a little bit of that stronger circulation. And this one doesn't actually end up showing any large storm, if you will, of profound circulation. And again, because it kind of keeps these two things apart. Let's take a look at the one right next to it, and let's see what it shows in this longer time frame. So I'll just jump right ahead to a bit further out, and let's see what it shows. So again, right there it shows a few powerful storms. Look at that one right there across the Dakotas. Boom, next weekend. No snow with it, but definitely a lot of rain and some decent circulation. That passes through. A bit of drying out occurs. But, the pattern does remain active. And look, it starts showing some stripes of snow into the Dakotas right there. And definitely a continued active pattern for the West Coast. Let's take a look at another one, P36, another ensemble. And look, so we have, again, not much activity up until next weekend. We start seeing the individual little bands of rain, again, a lot of moisture. And look, this one does develop a system, kind of two separate ones, if you will, really one to the north, one further to the south, disconnected, not too strong. But look at all that snow right there. That is impressive. That is showing quite a bit of cold air. And that's obviously not just the lower elevations. That's, potentially Salt Lake City seeing rain, snow out of that, which, again, is usually not in the mountains, and it usually sees their first snowfall around a bit usually later than this. So this would be definitely a bit early. Look at that, all of Wyoming seeing a system, and again we have that strong circulation, low prow. Dang it, jumped away. Look at that. That is definitely a fall. You could call that a snowstorm because of how expansive that snow shield is. And again, you could see that these models, almost every single one of them shows something like this. And look, this one actually goes to show another one, but developing snow across Colorado and western Kansas, and it brings more rain across the plains where it's not cold enough. So yeah, I mean, I would say that a snowstorm chances are growing because you could see these large systems are going to be passing through. There's another one. Look, just not enough cold air for it. Here's one further towards the east. Obviously, not enough cold air for it. And the models that do show a snowstorm just show that same thing that most models show. They just add a little bit of cold air to that. And again, a lot of them do show a lot of snow still. I would say all of them show heavy snow for the mountains. It's just whether or not it will be kind of across the lower elevated areas as well. Look at this one. Boom, blows it up, but across southern Canada. And again, I'm not showing you cherry-picked models. I'm clicking on random ones here to show you the pattern. If I were to show you cherry-picked models, I would go on 15-day snowfall, pick the most snowy scenario, which, let's see, would be not even, I think I saw a few more snowier ones than this. Look at that one. That is very snowy, but I want to see if I could find a even more snowy one. If I might as well show you a snowy one, might as well find a very snowy one. Let's take a look at this one. That one shows a lot of snow across Wyoming. I'm going to see if I can find another one. I think this is fun, just going through these models, trying to find out, look at what the different ensembles show. Again, a lot of scenarios showing very heavy snow, and you can see there are a few models that don't. But really, it's quite a bit that do. There's one that shows it again, keeps it more to the mountains, but it's heavy nonetheless. Here's one that keeps it towards the mountains, not as heavy. Look at that one. I want to look at that one. If I were to cherry pick a model, I would take a look at the 48th model ensemble, take a look at its precipitation outlook, and show you this is the only thing that's going to happen, right? But again, I showed you that. A lot of them still disagree, but look at this one. Let's see. So it showed that large area of snow. Let's see how it develops that. Again, in a very similar fashion, we have a lot of precipitation coming in from pretty much every direction, the north, the south, the Pacific, and really, I mean, either direction it comes from, it's really just the Pacific that it's its main moisture supply. Look at that rain band developing right there, kind of taking on that tilt. Again, that sudden sharp tilt, indicative of that strong jet stream controlling the weather at this time of the year. And look at that. Across the northwest, we see that snow. Obviously, that would be chilly conditions accompanying that. And look, it develops that snowstorm, a large one with lots of wind. And yeah, I mean, that's a classic beast. So again, that's more of an aggressive scenario, but I think the chances are growing. Early indications are pointing towards it. This is a long video, a bit too long, but thank you guys for watching. I'll catch you all next time. See ya.